Hello everyone, my name is Ryan,
My name's Javier.
and this is our team's presentation for our IoT group project. So for this project, we have decided to make a brand new version of the traditional pill counter that you've seen. Those usually go for around $1,200 up to $3,000, and they required a lot of mechanical moving parts. It's a pain to use, and the cost to maintenance is very, very high. So we set out to find a better solution to that by applying IoT aspects to it.
So to combat that, we used IoT methods. So we implemented a LED board that will tell you when the button is primed so that you can take a picture. We use data collection that stores the picture. Once the picture is stored, it's set into a web database application that can be used for record keeping to better adjust the precision of our machine learning algorithm.
Okay, so for this project, we decided to go with the ESP32 CAM board. It has Bluetooth and Wi-Fi capability, and for the bonus, it also has a camera attached to the module. So it's a self-contained module that has everything we need. It's perfect for this project. Okay, so this is our IoT project, nicknamed CountRx. What it does is replacing the traditional pill counter with a fully autonomized computer vision based machine. Instead of moving mechanical parts, all it needs is a tray and a camera. This makes for very easy maintenance, and it brings down the cost of a machine that can do this to a very affordable level.
All right, so this is the LED display. This is like a gain operator, which changes the contrast. What's supposed to happen is the display will tell you when the button's primed and ready to be pressed, and then once you press it, it'll be able to take the picture and give you the count.
Okay, so we got the server to work. So now the Arduino or ESP32 can connect it to a local server that will handles the image capturing and receiving to and from the Arduino. And once the picture is sent to the server, the code from the server based on OpenCV will do the machine learning that perform the count based on the image that this camera captured and sent back to the server. All right, let's test it out. All right, so here's the demo of our project. This is the first count on the CountRx machine.
All right.
Right.
Tell me when to prime it.
Yep.
No?
Yep. And as you can see, okay, now we flip.
Go ahead. Ready to collect? All right, we're ready.
Ready.
Thank you.
Yeah. We can just keep doing that part.
So for future implementations of this project, we would like to develop a web application so that users can have a richer interface that gives them and displays more information for them.
So there are a lot of complications when it comes to this project. Our team started around February, and time wouldn't allow me to go through every single one of those hurdles, but the biggest hurdle is the chipset that we decided to go with, which is a ESP32 CAM IoT. That board came without any pin headers soldered to, so that is one of the hurdles I have to overcome. I have to learn how to solder. And afterwards, because the board came with so many components packed into one, the Wi-Fi and Bluetooth modules, the camera modules, everything needs its own pin. So all of the pins are embedded into the board, and there's no way for me to figure out which pin was used and which pins aren't. It took me around, let's say, 4 days total time to figure out which pins are free so I could attach a button and a LCD display to it. And the end result, the LCD and the buttons do work, but for some reason the LCD does not like this board a lot, and 9 times out of 10 it always display junk messages and not what we want. So the goal here, well, this is part of the future goals, is to either find a similar LCD that requires less pins, say an LCD with an I2C connection, or replace it completely with a web application that we can just run on a mobile or tablet device.